Good evening to all. Welcome to BCF India International Webinar. Thanks for joining all participants and today's speaker.
On behalf of BCF India, I, Marina Johnson, intern of BCF, privileged in introducing our today's speaker, Dr. G. Areendran, Director of IGCMC, Coordinator of ENVIS WWF India. Dr. Areendran has an MS degree in ecology from Pondicherry University and PhD from Saurashtra University. From 1993 to 95, he was Research Fellow in SACON, also Salim Ali Center for Ornithology and Natural History. From 1995 to 2001, he worked as Senior Research Fellow in Wildlife Institute of India. He has also worked with other leading research centers like Madras Environmental Society, Chennai, and Institute of Remote Sensing from Anna University, Chennai. At present, since 2007, he is the director of Indira Gandhi Conservation Monitoring Center as a professional and a leader in geospatial technology and has been the driving force of location-based data monitoring and analytics since 2001 at WWF India. His work at WWF ranges from addressing conservation issues occurring in various landscapes with a high focus on the tiger, elephant, and rhinoceros to overseeing several institutional GIS-based projects. He has led the core technical team within WWF India to utilize current-gen technology and has always been a partisan for applying GIS solutions to overcome challenges within the field of conservation. Being an integral part of the WWF network, he has participated and overseen various international projects from understanding the impact of global forest fires, deforestation, and degradation to capacity building programs on GIS and remote sensing for staff at WWF Bhutan. Recently, he has spearheaded WWF India's geospatial and analytical contribution to UNDP's Secure Himalaya project and is the current coordinator for the Green Skill Development Program of Ministry of Environment, Forest and Climate Change of Government of India, wherein he has been regularly conducting GIS-based skill developmental training for youth. As a pioneer of geospatial education, he also supervised over 100 masters and research students. He has published several research papers and reports in peer-reviewed journals and were involved in the publication of 4 books in the capacity of editor and co-author. BCF is happy in connecting the eminent professionals, stakeholders, students, and public on this international webinar during this COVID-19. We are delighted to connect our eminent speaker, Dr. G. Areendran, Director of IGCMC, Coordinator of ENVIS WWF India, on this virtual forum and waiting to listen on Burning Menace, Understanding Spatiotemporal Distribution of Fires. Over to you, sir. Thank you all.
Thank you. Thank you for the excellent introduction. Thank you, Dr. Kumaraguru and the BCF for giving me an opportunity to share my knowledge in this forum. Well, this is again a topic which I'm very passionate about to talk about, especially with the incidence of fire in protected areas or in the natural areas. Overall, fire is more of a devastating effect on in the natural habitats. But to understand the ecology of fire, it really needs a lot of ground data collected on the from the wild environment, as well as to have a lot of spatial data and also satellite data combined together to understand the impact of fire on the natural habitats. We at WWF address many issues related to conservation using this technique, and one of our project which we did global fire analysis for the entire globe, which was funded by WWF Germany office. And interestingly, this study is going to be published in one of the well-reputed journal. And we did I just want to give a heads up on what we did in this project. Globally, we wanted to understand how this fire is spread. And last 8 years of data, that is from 2012 to 2019, what has happened with the fire situation pan globe. And I'll be presenting also a little bit focused on what has happened with India, especially all the incidents of fire. And we have collect this data is based on the satellite data, VARS satellite, which I'll be giving in detail how and what sort of data and what's the resolution of data. All those details I'll be talking in my presentation. The context of my study and my presentation is we need to first fire data has been collected from satellite point of view for almost last 15 years. But from 2012, the resolution and the quality of data collected based on the satellite makes more our work very easier, especially in understanding the temporospatial distribution. Especially, you can always do a lot of ground work where we understand local impacts of fire in a forested area. But at a pan a landscape level scale or pan India scale or pan global, what is the situation of fire, how it is spreading, what is a pattern of fire, especially to understand whether there is a permanent burnt area or there is a occurring of regular growth of fire is happening. There is an increase in the fire set incidence of fire, or there are some fires which is extinguishing and then new areas have been burnt. To get in spatial understanding, this project was done. It's quite interesting results came up, but I will be focusing a little bit on our Indian component, especially in the Punjab and Haryana area, where the crop burning, which has been happening last 10 years almost, which has been contributing to the pollution of Delhi. So we focused on that, and I'll be presenting some results on that. And also, my talk will be covering about the new technologies available, various techniques and analysis technique, and to represent the data. I'll be focusing on that various tool sets which we have developed. I'll be representing those things in this talk, which is through the WebGIS portal, and many GIS many. I'm sure there'll be a lot of students and researchers who must be knowing about how a GIS function. But this in my talk, I'll be talking a little bit advanced, especially advanced technology of using WebGIS portal, where these freely available data sets are brought in, analyzed, and represented in a more of a dashboard approach. Okay, now coming to the data structure, what we have in the analysis is how the distribution and the patterns of this fire occurring in a space and time. It's an interesting analysis which has been done for pan global, and it took us almost year's time to do this analysis because of computer timing and many other the data cleaning and all those things took us those issues we faced initially to get the data structure properly for running this. We used various models also in this. Also, it's an enterprise portal version. It's these days, which is highly upcoming technology, where the GIS is on more of an online base. It's no more, though the analysis is done at the desktop, but you can do a lot of online GIS analysis, and that's a new technology which is coming up and using artificial intelligence and machine learning. And I'm sure everybody will be aware of this big data, which is freely available globally. This is going to be the future technology which will be used in understanding these natural incidents. And also, one of the objective of the study was to translate this finding into action and support various protected areas. So when I mentioned that it is a pan-India study, basically we covered all the protected areas in the country and focused on few important tiger reserves. What's happening last maybe a decade, how the fires have behaved, how they are spatially distributed. We have done some analysis which are supporting those forest department with those analysis. Also, all of you are aware that Forest Survey of India is also parallelly doing a lot of high-end analysis. They are also having a live detection system as well as information system which helps Forest Department. Our analysis adds on to those results as well as give a better understanding for a better management. And I would also like to listen. The end would like to listen from all of you what your understanding of how this new analysis of the novel ideas can be brought into further management purpose, as well as your ideas of how I'm sure many educated, highly qualified researchers are there who will understand this ecology of fire. They may have many questions to us. I would love to have a more interaction on this. What is a necessary understand the impact how the fire is causing an ecosystem, especially on the biodiversity point of view. Of course, fire outside protected areas is a different, altogether a different lens we have to look into it, and fire within protected areas and nearby protected areas, we have to have a different lens to look into that, and both have a different devastating effect on, of course, not only the biodiversity, even on the, if a fire is occurring in a nearby protected area, outside protected areas, which is affecting the agriculture areas, that's also going to indirectly affect the biodiversity. And also, we want to understand how much of area is burnt. I'll be showing few examples. I'm sure everybody is aware of what happened last year in Australia, the bushfire. We were lucky enough to get those data. We've done some analysis to understand acre level, each acre, how much of acres and hectares. Sorry, in hectares it is burnt, and how the pattern is burnt last. Eventually from November to January of 2020, how the fire has behaved in Australia, and how much of area has been burnt. We have done an analysis, and I'll be representing this. Okay, now, of course, as a part of research, we do so much of analysis and so much of data sets are coming in, but it doesn't meet the final purpose until it is used by research communities and policymakers. So the final destination of any research or any analysis happening in this country should benefit the policymakers, or at least for the better management of whether it is a natural area or in an urban environment. Any analysis or any research papers which is published or any science, it should speak where it could common language which can help the local policymakers. So that's a point which we're trying to make. And especially in WWF, when we do, when you analyze anything, any data sets, and when you come out with publication, it reaches the policy level for the policymakers for a better decision makers for this better decision making. Yeah. Now coming to the prior analysis on global level, if you look at global data sets, I'm mainly talking about, especially this sort of analysis been done, especially number of fires in Brazil. Like if you look at the year from 2001 to 2018, 19, they have done a number of fires incidents. This sort of analysis they do. And also, if you look at they compare it also with how much of these fires occurred across the various forest types and various density of forest. But in our analysis, we have looked into in detail how spatially they are distributed, basically time and space. I've done a 3D analysis for one example I'll be showing today on Bangladesh, how a fire distribution in last 8 years, fire occurrence. I've just taken one example because globally, all the global data sets I cannot represent here, but it was one of the best that we could see how in 3D environment we can display in space and time of 9 years data sets for Bangladesh. Okay, landscape. What? Okay, now what are the impacts of fires at the landscape level? What it does? If you look at landscapes which are heterogeneously characteristic, they are actually landscape means it includes all the ecosystem, the structure, function, and also the temporal variations, which makes the landscape basically. And within the landscape, there are many. I'm sure all the ecologists will understand. There are many, patches level patches and distribution of those patch, and this patch size matters, especially in the biodiversity as well as a biorichness point of view. When the fire spreads, they are going to impact first all the small size patches, which in turn will impact the local, let's say in a landscape level, the local biodiversity is going to go off. That's the reason we need to really understand the ecology of fire. And fire has been much talked about these days, especially it's one of the protected area level management issues which is faced by all pan India, whether it is South India or whether it's North India or even western part of country where a lot of protected areas, dry deciduous forest protected areas are there. It's one of the major component of expenditure which is spent by the forest department, especially the tiger reserves or wildlife sanctuary, in controlling and protecting the forest from the fire. Of course, fire is a very important role in ecological management. But when it goes out of control, then the diversity loss is very, very high. And if you look at the statistics here, proportion of area burnt at force severities within per meter burnt, Greater Yellowstone, just an example, 19 old data sets we are given. Unburnt burnt, if you look at the area, just an example, I couldn't bring any Indian contest in this. We have data sets, but I would like to focus on something which has been well established studies. That's the reason. If you look at especially in India, we have more of a ground fire. We don't get much of a ground fire. Reason behind is that our ecosystems and our distribution of the forest is such a way that most of the fire in India, most 90, I would say 95% of the fire is caused by the human being. There's no natural disaster, unlike what's happening in US or Australia, where the natural fire is very phenomenal. But in India, it's because of human activity, most of the fire happens. Of course, in Tarai and Uttarakhand area, there are some, they believe to have some natural fires because of, the depending upon the climatic environment factors, natural fires are occurring, but mostly it is due to human being. And again, one important point is that when a fire occurs in a boreal forest, as example, it'll vacate the area, it clean up the area 15 to 20% of their around their each, 20 meters of each of their patch size. So naturally that disintegrate and defragment and also fragmentate fragmentates the forest contiguity. What are the effects of fire? To go broadly, loss of habitat, territories and shelters for animal. You can see it's not supposed to be displayed. I forgot to take this away. You can see a rabbit or a hare, you can call it, completely burned. So this is the ground fire which really devastates, which happens in India also. We also get a lot of animal killed in wildfires, which is happening in protected areas, especially in central India and down south also in Satyamangalam areas and Mudumalai. You must have seen a lot of fires happening, and it burns for weeks and weeks of time. Though in India we are lucky enough to have forest department, they manage it very well, and they distinguish. They completely put out the fire immediately within 2 to 3 days. So sometimes it goes beyond control, like what had happened in Uttarakhand in 3-4 years back. That it took them almost 10 days to clean up to stop the fire. So that's the situation. But unlike in what is happening in California or let's say recently, I'm sure you must be hearing about California, what's happening, and in Australia, which took 3-4 months, the bushfire to completely get extinguished. And also they degrade the vegetation. Sometimes fire are necessary in some, I would call it in protected areas, because it allows grass to come up, edible grass, which helps in the growth of the local prey species, and which in turn helps having a good density of prey species increases the tiger which is available for the tiger, which also in turn helps the tiger population to go. But when it is good, as I said, when it goes out of control, then it becomes devastating. And it also affects on photosynthesis, productivity, and seed capacity. So if the fire is going to burn and it's going to stand for a long time, the seed which is below the soil is also going to get affected. And imagine the commercial cost of timber value. Of course, we don't do any operation within protected areas in the country, but still the value, carbon sequestration value, it goes down when the tree is completely burned. And it's also going to affect the food web, and it's going to cause global warming, ozone depletion, and the structure of landscape change and the degradation of catchment areas. Naturally, because you have to have trees in the catchment area, so they can have a very good, like a wet capacity, so which also increases the flow of rivers and all those things. All those biologies involved in this. Local microclimate is going to help it completely get disturbed. And of course, the people who are living in and around the protected areas, the local rural and tribal people, they really get they actually face a brunt. And they are the one people who are really been, they support the forest department right in the prime stage when the fire starts. They have been engaged in extinguishing them, but they are the one who also get affected by this because of let's say in a long way, like where tourism gets affected. They have their agriculture land just outside the protected areas, which also get burnt, and their crop is burnt. So many. It's a chain effect actually. Then loss of food, disease, and following injuries. Animal gets injured, the creation of carbon monoxide and fire adapted fauna, because when a fire comes, the ecology and the regime is completely impacted, which again, on the selection basis, those species will come which are fire hardy. Naturally, that is not going to be palatable for for a local species, and they may compete with the local species, and the fire hardy species is going to continue, and that will change the competitive vegetation composition of an area. So more frequent fire, it itself is a different ecology in natural science, okay, and many other effects for that reason. Just to give an example, just given insight of what happened in bushfire of Australia, they almost lost the koala habitat, which I'm sure everybody would have read in many papers now. If you know that thousands of koalas went off, basically got killed because of the, and also this I have mentioned here. If you look at this, kangaroos, wallabies, gliders, kookaburras, cockatoos, and honey eaters, they've been impacted by this bushfire. Bushfire is the worst what had happened in Australia last year. I'm sure everybody is aware of this, and it will take many decades to get those, and many went into extinction, completely locally extincted species have happened because of this fire. And if you look at the fire across Kangaroo Island in South Australia, I'll be showing an example. I'll be showing actually a data analyzed for 3 months of November, if I write November to January, I guess roughly of 2020. I'll be showing what happened in Sydney, how the fire, the simulation based on the data. I'll be showing also those slides now as the talk goes on. And fires also, they have burnt a critical habitat of native mammals, especially the long-footed potero and mountain pygmy possum. It's bad. Yellow-bellied glider and brush-tailed rockwell. These are species which already, like within a year, they've found out what has happened because of this critical fire which happened in Australia. And threat to koalas mainly. The koalas could be extended wild in eastern Australia. Australia in 30 years, excessive tree clearing anyway was happening due to the agriculture and urban expansion. Now this fire has added oil to that. Imagine, not having any trees for the koalas to survive naturally because of the bushfire. Now koalas also got a lot of them burnt, and this population is completely gone down in the eastern Australia. And also it's not only affected in the bushfire, not only affected the animal as well as it also affected the eucalyptus tree, which is a koala's habitat. Many completely burnt down. So naturally, when there is no eucalyptus tree available, how are you going to reintroduce even the koala into that? And it is going to take years to come back. So it has a chain of consecutive effect when the fire goes uncontrolled. So that's a reason that we need to understand how a fire works. Of course, the fuel loads within the various forest type plays a major role. The terrain and the environmental condition plays a major role in these fires when it occurs. So we need to really understand the ecology of fire, how it spreads, and how it can be controlled. And it's not that you can there's a 100% solution to that, but a better management practices can be understood based on the analysis we do how this fire behaves. Other impacts, I would say, I was just talking about mammals. Well, but there are many other life which is getting completely affected by this fire. Impact on the insect world. And insects are very important for pollination, amelioration, and food chain. Imagine there is no pollination happening. How are you going to get your food produced? Once you lose the cycle of bees, flowers, pollination, your food chain is going to food production chain is going to completely get lost. Imagine within down the line 3-4 years when there is no productivity, naturally the agriculture system is going to fail. That in turn is going to impact us. So that's one of the, not only the insect is going to get affected, down the line 5-6 years down the line, ecologically we also will be impacted. Amphibians, that they also been very badly impacted, and especially they lose their diet and local extinction happens. Reptiles, these are the small invertebrates which gets affected badly due to this ground fire. Not only fires, of course, birds. You can imagine, you might be thinking that once a fire happens, birds can fly away. But how long? Where? Where they're going to find? If they're going to find a suitable habitat, you don't get a good habitat to fly back. Some get, and they have to fly, leaving their nests and chicks and everything. There's no way they can carry them. So that's the biggest impact on because of fire. And also the mammals, shrinkage of habitat corridor, the behavior is going to change. That's going to impact the overall, the biodiversity of an area. Now I'm coming to my main talk, my focus talk, basically, how this data or the data source and what I've used in analyzing this fire, what are the details of it I need to explain all of you. We have used the visible infrared imaging radiometer, that is VIRS. I'm sure remote sensing guy who are listening to this will understand this, which is of each pixel is 375 meter. It's a satellite data, NASA based, and it has it used to be there right from 2006 or 7, if I'm right. But 2012-13, they have this special filter, as well as a special, this VIRS image radiometer, which is very good in understanding what is on the land, especially on the ground, what is actually fire, what is not a fire. They can differentiate between, and they can capture that based on the heat radiations, which was not happening earlier, data sets. So there were miscalculations of fires and fire incidents. But now available of this VIRS has improvised our analysis and prediction, simulations, and the accuracy of our analysis. And it's a moderated, from the MODIS, basically, MODIS datasets. I'm sure many of you will know this MODIS datasets, which is freely available. And also, it has improved night performance. So in the night, to differentiate between the fire and the light. So that's very important of this data sets. And also, near real time, you can get the data sets, alerts, using this satellite data, which is transmitted globally. Services is transmitted globally for fire alerts to various departments of the world to warn them in advance, or when the fire is happening, the incidents and the locations are transmitted in such a way that the management of these fires can be very effective. So to give an, if you look at the pictures down here, what I've attached here, you see these colors, various. So you know that 88, 89, these are the pixels which has to be considered, of the satellite data, which are correlated with the fire. So these are some data sets. I'm just trying to explain how fire, when it is increasing, if you look at the same area, how it is increasing slowly. By the time, as the time increases, the fire is increasing. So that can be monitored. Yeah. Now, coming to the data set, I just can't use it directly, the data sets. I need to do some filtering of these data sets. There is a reason for that. Even after using VIRS data, which is well refined, available, one of the best data which is available, you need to remove those data set which has a low confidence. Reason is I will show a picture of in fact on analysis slide of one of our analysis in Uttarakhand, that is in Tarai landscape. We would call it a landscape because it's a one of the beautiful before the mountain starts in Himalaya, this in Shivaliks and Tarai, these are the belt where you have a very good productivity, especially it is in the plains of Ganga, where a very rich fertile soil, good forest, and a lot of agriculture is happening there, and large density of human being is also living in these plains. Now, the nominal fires remove potential sun glint. So that's a reason. So if you use a high confidence the data sets, you remove the sun glint. If I have a low confidence data sets, if I use sun glint, also is actually contaminating the data sets, and we assume that the reflection back from the ground, not due to the fire or because of some reflecting agents from the ground. It could be a terrace, or it could be even a reflective, let's say sheet, metal sheet or something. It could be anything which could, even a water, which reflect back sometimes is wrongly considered as a fire. So remove this anomalies. We need to filter the data. And when you use a low confidence data and a high confidence data, you will see what is the impact. I'm just going to come to that. And also the high confidence data, fire pixels are associated with day or nighttime saturated pixels and they are removed sun glint. Okay, now I like to show this analysis using both the low and thank you. So if you look at this, when I said that low confidence data and high with the low with and without low confidence data, basically. So if you look at this, if I use without a low confidence data, and if I use with low confidence data, you can see the differences. What happens here is, like, if you use the low confidence data, the fire is very smudgy. You cannot able to differentiate the brighter spots here. It's very difficult to know the real the correct locations and the extent of the fire burnt. But when you use without a low confidence data, that is what do you call in the data sets, which is from the VARS, the spread is more. It's more. You have multiple coming up, multiple spots which is coming up, which may not be true because of, as I said earlier, many sun glint is also coming with this. So it's better to always use a high confidence in the air. I have not mentioned as a high confidence here. Better data sets. We have to clean up. These filters has to be run. So that's one of the first step of using this VARS, especially when you are doing a fire analysis. I'll go back to my presentation. Then I'll one second. The analysis, actually, what it talks about is understanding their distribution and pattern in space and time. So last 9-8 years, that is 2012 to 2019 end, what we have done is till 2020 January. What we have done is we have clubbed those data for any location pan global, and we have clubbed them in such a way that we need to understand that if the area is burnt multiple times and in a multiple temporal times in multiple years, it's very difficult to show in the same overlay. So what we do an analysis called space cube time. Space cube time. That's an analysis where it's a different, statistically it is done to understand how the fire has behaved in last 8 or 10 years. It can be depending upon more and more data sets you use, you understand better, and it gives a pattern of how the fire is behaving. Whether it is it's a historical fire, or it is existing fire, or it's a fire which is happening is growing in as a time grows up. I'll be showing those results also. Okay, now we use this something called space-time cube by aggregating points which summarizes distribution of points. And one of the important is that I have used all of this in an ARC environment, that is the ArcGIS environment, where a net CD feed data structure is done. So here in my case, every 6 months data I have compiled. So we will have, like, in a location for 8 years, if there is a continuous fire, it will be 16 cubes will be formed in that area. The reason is we can't have every incidents in the same location separately shown in a 3D. It's very difficult because the fire keeps burning over. But we need to have the count happening in that area every month, every second month, 6 months, whatever. So we have just compiled because of 6 months is better, more than a better time period to understand the fire ecology for each cube. So for 8 years of our data, there will be 16 cubes in a location, which will be represented. I'll be showing for the Bangladesh data how it is done. We'll get a better understanding. Within each bin or the cube, you can call it. Bin is the one point. They are counted for 6 months. They are aggregated actually, and in a spatial and temporal, basically in time, that is years and months put together, and the location. That's a spatial pattern. And we also understand in a long run, once you do this analysis, how these fires are distributed, which will be the final results, which I'll be showing. Okay, now here, this is how it is done. The location is one area, let's say, and if you look at the location over time, location with data. So these are different bins I'm talking, 1, 2, 3, 4, 5. So in a year, let's say 8 years data, this is just an example. So each bin will be 6 months of data. In my case, what I've done is 6 months, I've compiled it together. It can be 1 month, it can be 2 months also, but it doesn't make sense to have 1 month or a 2 month, depending upon what is your requirement. In my case, it was just 6 months. And also you need to have an excellent computers, not supercomputer, but high-end computers to run this analysis, because it's a 3D analysis basically. So in my case here, each cube which you are talking about here is, if you look at this cube sort of thing, this is bin, I would call it. Each bin will have 1 year, 6 months, 6 months, 6 months. So it's roughly, it's around 6 cubes is 3 years. In my case, it will be 16 cubes because it's 8 years. Example of Bangladesh, and I'm sharing that with you. Bangladesh fire. Okay. Now, if you look at this, is what I was talking about. So, the spatiotemporal distribution of fire using a space-time cube. This is what the analysis looks like. So, I can actually, it is done for Bangladesh. If you look at this, look at how it goes. So, 3D of a location. You can go to the ground level. So here, what is the pattern? What I'm trying to say is, like, each location will have 8 bin. I remember I was talking about bin. So bin is here, in my case, is 6 month compiled data of a location. So each will have its own. So let me click on this. As I'll click on this, it'll zoom to the area. You can zoom in also. So on the ground, this is and you can have a look at the. Okay, I can have a look at this, and it'll tell me how many count of fire is 14. So in 6 months, there were 14 incidents. In 6 months, so each cube is a compilation of 6 months data. So each, in a 6 months, you had 14 data sets. That is 14 times this area was burnt in 8 years. So as I increase the year, this will keep changing. For now, I have done it for 8 years. That is 2012 to 19 roughly. And if you see, it will give you the starting date, December 2012, end there is 13. So in 1 year, there was 14 burns in that area. But after 13, there was no burn. So this is the beauty of doing such analysis. We'll understand in a location-wise how it is done. I'll go back to the 1 second. Yeah. So if you can zoom in, you can zoom out, but all depends upon your bandwidth and your power of a machine. And if you look at this, if I click here, you will get here nothing has happened. So it's more gray. So the color distribution also is like that. More bluish in color, you will understand the count of fire is more in that area, and the location. And each is so. If I click here the same location, it will give me what is the start date. So June 29 to 18 and December 18. In 6 months, there was 0 incidents. Same year. So if it's a light blue color, let me have a look at that. I can rotate mine. See, that's the beauty of having a 3D space and time. You can zoom anywhere. I can zoom to this point here. I can zoom here. It'll give me, if I zoom in, I can go. So I understand better. So in Bangladesh, at this location, there was count of 14 in 6 months. That is from December 29-15 to June 29-16. So this is beauty of doing a space-time cube analysis. I've done it for entire globe, but I can't display it here because I don't have enough power or computer or neither bandwidth to help me out. So I just gave an example how a 3D space-time cube helps you in understanding the distribution of fire over a space and time. Okay, now I come back to my what are the statistics behind this? The hotspot analysis, basically it's called, to understand the pattern of fire, how it is done, and using this space time cube analysis. What happens in this? We have used the data sets in such a way that we have used the Gettys-Augy statistics. It's called Gettys-Augy statistics, which is spatial statistics, which is available within the ArcGIS environment. I'm sure whoever the GIS person is, they'll understand this. to use this data sets over the time and space, because it's a 3D set data sets, and use the statistics of Getty-Saugy, and this is how the data, the analysis output will come. So it will let me know where are the new hotspots happening. So it also predicts based on the the number of data sets what I've used, and it will predict me where are those areas likelihood it's burnt. New hotspots are coming up based on the data. Consecutive hotspots, intensified hotspots, persistent hotspots, diminishing hotspots. Each has the same own. I'm sure everybody understands this. Sporadic, regularly happening, oscillating, sometime and burning, not burning. Historical hotspots, those areas in my case 8 years. Some were burnt for almost 2 years, and it didn't burn after that. New cold spots. Cold spots are those areas where fire once occurred and never happened again. So this is a various category of data sets I can use, the Getty-Saugy, and I get this data, this displayed on my map basically. And also no pattern. There is no pattern in the in a fire. Once in a while it had happened, a random fire incidents would count. Imagine lakhs and lakhs of incidents are counted based on the satellite data. Their counts. Every incident is taken into account, which is not possible. Why I've used this technique and technology and remote sensing data is that it is not humanly, physically possible. I'm sure everybody is agree to this, and neither will do justice if you're going to do a sampling and do it. So the other alternative proxy available is the data satellite data sets, which is more reliable than doing it physically on the ground and getting a pattern of what's happening on the ground because of this fire. So if you look at the data sets here and the cold and hot spots trends using Getty-Saugy, the hot spots are those areas where regular burning is happening and more burns are happening, and cold spots are where once happened or it just never happened also. No fire happened in certain point, because when it data set is collected by the satellite, it's going to collect everything for fire. It's like digitally 0 or 1, whether fire or not fire. Not fire, never fire will come into into the cold spots. And to strengthen our analysis pattern, we use this Mann-Candle test to do a Z-score and probability value on the data distribution, how it has helped us understand our distribution, whether it's a random or non-random. Okay, so we've used the data sets, and we have, if you look at this at Z-square, both negative and the positive, that is minus 2.5 to 2.58 in our case, and the probability of 0, 1, 99%. Our data sets falls, the random falls within this bell curve. So that's the level of accuracy and analysis, the data sets which is collected from this satellite data, which is used in test is very important to get an idea of whether our hypothesis, how good it is, whether we are going to reject the null hypothesis or not. Okay, now coming to the what the analysis and the results and the tool which you developed, which I had initially said, how this fire. Okay, I can do all this analysis on a GIS, just shows a map, but until it becomes an interactive and analytical tools are implemented, it's not going to really give us an exciting results or understanding of what is happening with the ecology of fire. So we built this tool using ArcGIS enterprise version. I'm sure many will be aware of this. It's a new technology which is upcoming in the country, in the pan world also. Of course, there are many. This is in it's a proprietary software from ESRI India, ESRI Redlands basically. And there are many open source also is available, data sets and open data platforms are available, which are high-end programmers and coders, they do the WebGIS. But we have used this technology because we are still conversant with this, and it has a lot of tools which are very easy to use. So I'm going to take you through this tool which we have built up. It's very important for you guys to understand. I'll go back. I'll start you. Okay. So if you look at this, this is an online version of our analysis which is published. It's not for public, honestly. It's very difficult to share it publicly. We are still building up the app application the web portal, and all our analysis results you can see here. So if you look at this pan, and we have just focused now today for the talk. I've just only I clipped the pan global stuff. I'm only showing the Indian thing. And if you look at this, is the portion of Delhi, the Haryana and Punjab area where the burning is very high. Many other places also you get Tarai and all those areas, even Central India, down south also you can have. South portion also we have fire. We analyze the fire, but I will be focusing on my which is very predominant fire occurrences in north of Delhi, because all my results I'm going to focus on this, and all the tool which I have developed will be. So if you see, these are the protected areas. Protected areas, I'm sure everybody is aware of. In Tarayar, it's Corbett Tiger Reserve. This is little bit, if you come, some are in Nepal, some are in Dudhwa. All those, these yellow colors are various protected areas in this area on the map which I've shown. So Dehradun, close by, so Dehradun is a Rajaji National Park. Then you have Corbett. So if you look at this color here, all of you must have seen, I'm able to see this. You can imagine the impact of fire incidents or fire which is happening due to the crop burning happening in Punjab and Haryana. So that's why the reason I have focused on this area. I'll a little bit zoom in also. Yeah. Now, how does this tool or these applications which we have developed is going to help the public users, or let's say even for that matter, any management or any administrative. So here, what I've done is, if you can click this, you can use a filter. These are the developed by us. So I apply. It will give me a result pan India, but now I focus only for this window. So naturally, the result is going to come for this area, the focused area. That is, to the extent of this window, we'll get the results. Yeah. So if you look at here, you get the historical hotspot area. So I go and click here. It will show me those areas where the historic hotspots are there. So this is the benefit of having a interactive online web GIS portals, and including which can be done on it. So if you zoom, so you can, these are the historical areas which has burnt. So now coming intensifying hotspots, which is, if I click here, it will give me those areas. One second. Yeah, it's still not complete. It's still running. If you look at there will be, yeah. It's supposed to show me the number of counts in that area, but it's because of internet bandwidth. Yeah, just a second. So if you look at this pattern type count intensifying hotspots, there is the meaning, every year, last 8 years, these are the spots where fire are regularly happening, and it is increasing. It's increasing. And look at the count for 8 years, 4,462 incidents of fire. So if you look at this in these areas of Punjab and Haryana, how it has come. Now, persistent hotspots. So regular burning every year, it's happening. So if you look at this, these are the space. These are those red spots which will give you persistence, and there are 856 counts. And sporadic, sometime happens and randomly it happens. If you go to this, then it'll automatically show you those areas, these fire places. So imagine if I do a system like this for any protected area in the country, to understand what is happening and how much of areas are burnt and how the fire is behaving last 15 years, let's say 10, 20 years. Difficult to get 20 years, but with the situation of the satellite, we have lost 10 years. You can know how to manage the park better. And these interactive dashboards helps you in understanding the pattern, distribution, and also on the ground, the ecology, how it is going to impact on the biodiversity of the local protected areas, and also gives them a decision-making support in managing the fire better. And if you look at this pattern type count, sporadic hotspots also in this area is 3,039. Of course, this is not the actual situation. Like if you look here, this is all crop burns area. It's outside protected area. Protected area also have similar, but the count may not be so high. So don't get bugged up by what's happening. More probably our protected areas are burning. No. Very few incidents. But that doesn't have much of 8 years. We didn't have much of burning data, so I've just focused on Punjab and Ludhiana to show you that. Okay, now what are the other tools I have? I need to show you all the tools now. Okay, bear with me. We have also plotted our z-square. Z-score also, it's very important to understand. So what is the difference? So how our results are that was the pattern of forest, the pattern of fires distribution. And this is the statistical distribution of those fire incidents. So you need to understand how the Z occurs. So but this hotspots where likely many burns are, that is 2.49. The Z score is very high. So we are right, and the data set speaks the correct. Okay, what is actually happening? I'll tell you. We are not what do you call? We're not using raster data sets here. I'm sure GIS people will be able to understand. That's a different talk I had to give about this raster and vector. We have used the actual vector here. We have not done any extrapolation of data. That's very, very important. I would like to address to the listeners here. We have not used any sort of manipulation or extrapolation of our data sets. We have just used the incidence to show the actual impact and the extent of fire which is happening. If I do an extrapolation, I am sure many of the people who are sitting are your plot. Once again, it's taking time, but you need to understand how it works. So if you look at the for that case, any persistent hotspots also, if you look at the score, it's around 1.13. And the count is z-square and count is 1. So if you look at the statistical also prove that our data sets is what we use is very less randomness is there, and very good data sets we use. Now similarly, I can get into the p values. Okay, I don't want to go in the detail. Let me show also the median counts, which is very important, that each count how it is, each single incidence, how number of incidents happened in the total in the bin sets which you have done. So this each fire instance is separately treated as a data here. So that's the reason it takes so long. So if you look at this, so we look at that two, so number each different counts. If you look at that, the incidence and number of median count 4. So there are 889 in this. So each wise, like if I look at the count here, 2000. So that 8 years we have distributed, and number of count for each locations we have taken into account. So just to show each incidence in each locations, how many number of times the fires are picked up. It's all, and again each, I said this data set's pixel size is around 350 meters roughly. So on the ground, so much of, if there is a fire of at least 350 meters and and above, it is easily picked up by the satellite. Of course, a lower than size of that also is picked up, but it's better easily distinguished fire spots comes out if it's above 350 square meter. Okay, now coming to the next tool, I would like to, you also can do some queries. You can do some situation analysis in this case. So if I do this will show me the number of features in this window size. So I can keep moving. This will keep changing accordingly. So it will change. The number of features here is 8,934 incidents each box wise, and significations 85. So this gives you the value of each different behavior of fires, how it is happening. So it'll keep on increasing. Now the internet is slow, so it's taking time. I also can do a 1 second. Unfortunately, that's yeah. So I can also draw my own my box here. Okay, so I draw a small box here, and it'll give me roughly the summary of that area. So if you want to understand each area wise, only this much area, let's say I put a box in to understand. Number of features here is 1848. Signification hotspots is 97% of it, and z square is z square is around 2. And if you look at the sum of bins, that is the incidence actually, is almost 1,17,000. So this is the power of this tool. Online you can keep checking. So it's very useful for the management as well as for the district administrator to understand what is happening. Okay, this is one part of the tool. Now we also have I have filter for this. One second, let me clear it up. Yeah, I also have a filter where I can do by various protected area level if I want to check what is the fire status in that. So I'll just give an example of it'll take some time. Yeah, so let's say this is in Madhya Pradesh. I can zoom into this, and if I apply naturally, it'll go to that protected area, and it will zoom and show there are 2 incidents of fires in last 8 years, major incidents. So this is the level of this tool which can help wildlife management areas as well as also outside protected areas by the local administrator to understand how this fire is behaving, and based on those satellite data and also the analysis which we give them, and this is automatically we can also update regular. The system is built now, we can keep updating regularly, and we can also update the latest data. So we are working on the 20 data sets, and as now October, November, now the burning has started in, especially in Punjab and Haryana, which we will update soon by December, and we'll be publishing it online actually. Okay, now coming from, there are many tool sets. I don't want to really take much time. You have Legend. You can also print your this data sets. You can take a printout and you can have it in a PDF format. You can change your background layer. Okay, these are the various tools which I wanted to explain here. Now coming to the most important part which I was talking about is the distribution of the bush fires, which we have done an analysis. I'll just like to take you there once. There are 2 way of doing this. One is the overall incidence data we have collected together. 1 second. Which I was talking about the forest fire especially. So if you look at this incidence, so from October 1, this is collection of every 10 days, how the fire incidence. We have collected only, and we have done an analysis. I'll be showing one more application where each incidence of burn, each acres of burnt or hectares of burnt is mapped. That I'm going to show you separate. Here, if you look at this overall, the behavior of fire, the spatial behavior, the spatial temporal behavior of fire, how it is done. So if you look at from this map, it's done an analysis based on the real data from satellite as well as from the ground. Verification has been done. So if you look at here, in October 1 to October 11, that is 10 days. To see, I like to zoom in at certain point of, let's say Sydney part, so that people understand what's happening in, yeah. If you look at the Sydney part, let me run it. Yeah, I'm sure you can see this. I'll run this. You see how the fire behaves in almost every 10 days. See, in 20, it didn't have, then it's taking time because, yeah. See this from November 20, then again December. 1 second, let me stop. Because the refreshment of the data is not happening. Otherwise, you will be able to see the. So if you look at the Sydney and the nearby forest, which are the one of the highly impacted areas of. So if you see, it will keep changing automatically. And this is a based on the analysis in the graphics. 1 second, let me run it. So slowly, if you see, it kept increasing. The first week, second week, it went to the big. It went to the by December end and January it went up. They were able to control it. Unfortunately, my the speed bar is going and the data set is not getting replaced or displayed because of the internet bandwidth problem. So let's see automatically what happens. So if you see these areas, these are protected areas, high good forested area of Sydney protected areas, which are slowly increasing. I'll move it slowly. Let me stop it. So this will change automatically. So this is how display and visualization of your database or any for such as see how it is changed. By November 20, it really increased to the maximum, and you can see the size of the protected area, which has bushfire, which has happened. I'll again run it, then I will stop it. Then you will see the change. Unfortunately, there is no coherence between the data displays and the speed it is running because of the bandwidth and the server linkages. So this is one point which I want to explain, how this technology and tools and analysis helps you in understanding the the fire behavior, especially which we have done. Now I'll take you to the other part of it. Actually, this is the one which I was talking about, where every hectare of the burning is calculated for last from October to January. In fact, mid of Jan, and we are able to map every smallest point on the earth in Australia got burnt, and you will see how it is displayed here. So I hope the data set is displayed properly. So it will tell me each month wise how much of hectares burnt. Unfortunately, it is not getting displayed because you will also get those points, and it will give you roughly with a graph how much of area burnt. But it's not getting refreshed because the bandwidth. Unfortunate, very unfortunate. Let me wait for a minute, otherwise I'll try and. So these tools are available. My point, all your data sets you can administrative or to the research community, because it's very, very important. This deep analysis, this science findings are these and administrative for that. It's not a very great rocket science. It takes some time, maybe 2 months time or 3 months time to understand how to do this analysis, and it can be shared with the public, more of a knowledge sharing actually. I am very unfortunate. I'm sorry, but I'm not able to still show you this one properly. Data sets or this technique can be adapted to come out with results, and it's also statistically also it's been tested, and it's a foolproof data model. We are publishing it. It's been accepted also, sort of. And it's very interesting to understand what is happening with the fire situation, pan India, pan global. And interesting is that we're not done any interpolation. The most important point is it's all the original baseline data we used here. No interpolation we have used, and it's easily available, freely available data. Little bit of processing is very much, very much. Processed data is freely available, to be honestly. We don't have to do much of processing on the lab, except that you have to compile it, and according to the spatial and this time, that's the only compilation you have to do to get a better idea, and depend upon what objectives it was to do this analysis. Otherwise, these are all not. These are all interestingly free, set of analysis which can you do at a desktop and give a better, do a better science. Especially in my case, it was more of a fire. Also, many other, even flood monitoring. We are doing flood monitoring in Kaziranga, especially for using the Brahmaputra water data. That's also interesting analysis, which I probably later sometime I can give a talk. So these satellites which are coming up, and with high resolution data sets and accurate data sets and spatial and temporally distributed data sets are now freely available for public to use and do some analysis. Could do some good science, especially which can end up in the hands of administration for a better management. So that's a point of showing these sort of visually enriching results. So saying that, I would like to now end my talk. Thank you.
Thank you, Doctor. Thank you for making wonderful presentations. Learn new approaches on conservation through today's presentation. Thank you, Doctor. Thank you so much, Doctor. Thank you so much for all participants.
Thank you very much. Thank you.
Thank you.